into part one and part two. Again, let's get into the part three. I'll just introduce part one and part two. What are the things in the part one and part two? Okay, let me just present it. Okay, fine. This is a basically a end-to-end project. We'll be discussing a end-to-end project, which is like production grade project. You will have all the CI pipelines, CD pipelines, infrastructure provisioning, and multi-region approaches, and many things. That is the main priority. Again, this is the old architecture. Let me show you the part one. Again, in the part one, we done is that we created a AMI. AMI means Amazon Mission Images. It is not centric to only AWS, but you can always create in the GCP, VMware, and Azure also. There is another name for it. Again, the concept remains same. Okay, that is okay. The concept remains same. AMI means you will have multiple softwares. It is like a template. You can assume that it is like a template. You can use that template to automatically, let's say uh, you want to create an EC2 instance with multiple softwares in that. Let's say you have Docker, SSM, and Docker Compose, and many things on the top of EC2 instance. Okay, this is my okay. That is the thing. You want to create that AMI in this part one. In this part one, we'll use something like HashiCorp Packer. Using that Packer, we'll create the AMI. Again, this Packer AMI will be using in part three. I'll be saying about how we'll be using this Packer AMI and what are the users and how it reduces the downtime. Again, this is a part one. If you want to just see about part one, you can visit my YouTube channel and just watch it and implement it. That is the main thing. You can't watch it like a movie or something like that, right? Yes, these are the things. Again, the second one is a pretty simple thing. Again, you will have some of the scans running in the part two of our thing. You have Snake scan, Sonar Cloud scan. You have multiple scans like Trivi, JFrog. You will push the jar file into the JFrog. If you want to get a depth into this, you if do watch that part two video in my YouTube channel. Okay, this is the uh, difference between. You can say that part one and part two introduction. Okay, let me get into the point. You are waiting for a lot of time about part three, right? Okay, let me see if I can. Okay, anyone did understood from this architecture? It is blunt, right? Hello, guys. Hello.
Yeah, it's a bit hard to
It
get this.
is, yeah. It is hard to, it is a very big architecture. If you, even the architecture is very big and you have multi-region, blue-green deployment, CloudFront, CDN, Crossplane, everything in this total architecture. And Deepak is saying that this is part three. You may think that part one and part two are very big, but the part one and part two are very small kind of things. Again, here is the main part. Here is the main part, that is part three. I will discuss all these things, and yes, we may not deploy everything. We may not use crossplane in this process. We may not uh, deploy all the things, but I'll say about these things. How can parts? How using Terraform and crossplane. I'll show you in the live part, but the main idea is that you need to have idea about these production processes rather than those tools. DevOps is not like a tools kind of thing. You need to have a strong idea of process. What problem we are solving in this process. Every tool, let's say every tool has every set of problems, and every tool has every set of solutions. We need to know that solutions and problems to overcome, to be a good DevOps or cloud engineers. That is a fundamental idea. In YouTube, you may see like many course sellers just deploy static website and just say that you keep this static website hosting in your resume. But recruiters don't impress by that kind of things. They want like process oriented stuff in their in their projects. I mean, they wanted they want to hire someone who has a great knowledge of how process is going on. I mean, you need to know. Uh, how many of you know that engineer means solving problems, guys? Hello.
Yeah, I know that.
Yeah, yeah. Engineers means solving problems. DevOps engineers and cloud engineers need to solve problems, not at all integrate all the tools and just to know that in the DevOps and cloud there are hundreds of tools. You cannot learn hundreds of tools, but you need to know the client requirements and get that job done. That is the thing, right?
Yeah.
Yeah, that is the thing. Okay, let me get into the fundamental part, fundamental architecture of it. Okay, okay. I mean, I just my yes. This is a fundamental architecture. I mean, the smallest breakdown kind of thing. Okay. Here, if you see that you have multiple things like public subnets, private subnets, secure subnets. Okay, this is the thing. Here, if you see that this is a VPC, and one more notice that I may not say like everything. What is VPC? What is public subnet? What is private subnet? Everyone know what is VPC and what is private subnet, right? I mean, these fundamental concepts, right?
Yeah.
Yeah, yeah. That is what I am expecting. I can't be a course. I can't make a course around it will be like 10 hours or 20 hours to teach all these concepts and the project. That will be kind of messy. That is why I want to focus on this project only. That is the thing. Okay. Here, if you see that there is a VPC, and in the VPC part, you have a internet gateway to allow the traffic from the VPC. Yeah, this is a basic structure every VPC would have, and there are two availability zones. Okay, there are two availability zones. I mean, you have this is a AWS driven approach. I mean, if you see AWS documentation also, they will say that you need to have two availability or three availability zones as your base approach, uh, because if one instance doesn't work, again the traffic will be shifted to another instance. And there are many advantages for the availability zones concept also. We will discuss it later, but still availability zones are like uh, multiple subparts of the region. That is the thing. You will have you will deploy this in the two availability zones. You can select it according to your region. I mean, yes. The next thing is that you have a public subnet. Okay. In the public subnet part, you have two NAT gateways. Let me introduce the term NAT gateway. NAT gateway. Okay. Okay. Someone joined now. Okay. Even though if you join now, okay, you can view from this. Okay. This is a architecture. Let me show once again. This is the architecture we'll be discussing, and this is the smallest part. I mean, this is a part first will be discussed, and the same part replicates here also. So you will be understanding how multi-region works and all these things. So this is a
Can
part.
I just ask a quick question?
Okay.
So, what is sort of the aim of this project? What are we trying to achieve? And is this eventually going to be deployed for someone? Like, is this you said this is a production level project, but are we then eventually going to give it to a client? Do we have a client, or what's exactly what we're trying to do here?
Actually, okay, actually to learn how production, like how production systems work. I mean, if you see here, let me if you see here, according to the client, as I said, if you see the part one, I mean, according to the client requirement, we have uh, disaster free architecture. I mean, he said that it needs to be disaster free architecture, and it's need to be blue green deployment, and these all strategies need to be applied on that. On the client's word, we are deploying all these strategies. I mean, even in the production, if I am a freelancer. I mean, I have worked in the multiple projects, 10x larger project than this. In the production grade scenario, you will have multi-region approach. I mean, that is the main aim. You need to know concepts. I mean, how process work. That is a main thing.
Yeah.
Okay.
Okay. And then, all right, cool. So I suppose in these parts we just discussed the overview of this that you have designed, and then are we eventually going to build this at some
Yes.
point?
Yes. 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 We'll be building live.
Okay, perfect.
We'll
Thank
be
you.
having some domain name. I mean, we'll be building live.
Perfect. Thank you.
Yes. Yes. Here, if you see that in the VPC, we have a public subnet. I mean, what is a public subnet? Public subnet means uh, in a public subnet, you will have a IP address associated with it, a public IP address, mainly a public IP address associated with it, and there is something like NAT gateway deployed here. A NAT gateway means, let's say this is an instance, right? EC2 instance. EC2 instance need to download any packets from the outside world. So it will just go to internet gateway and just access packets and just download something or something and get those packets done, download done. But here in this process, there is some problem occurring. Can anyone say that? Hello?
There's a problem occurring with what exactly?
I mean, if you want to access through internet gateway, some problem will occur. I mean,
So we don't.
let me say that. Let me say that. Okay. Let me say that. There is a problem like IP address will be, I mean, what to say? IP address will be
Not consistent.
exposed. This instances IP address will be exposed to the outside world through when we are using internet, simple internet gateway, right?
Mm-hmm.
That is why we are using NAT gateway. NAT gateway is a AWS service in which NAT gateway does masking of the IP address. Okay,
Yeah.
masking of the IP address and send it to through the internet gateway so that you will have IP address is secured, and this is a process done in the industry also. I mean, you will have a NAT gateway having in the public subnet and the instances in the private subnet so that the security will not be compromised. Yes, that is the thing. We are using, as I said, we are using NAT gateway in the public subnet, and there is one more component in the public subnet. As you already know, that application load balancer. I mean, it distributes the traffic across the instances and compute compute kind of things. Understood, right? Hello.
Yeah, that's all clear to me.
Yeah. Okay. Fine. 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 Okay. Next thing is that we have a private subnet. As I said, the fundamental difference between private subnet and public subnet is that in the private subnet you will not have any public IP addresses assigned to it. Let's say you have an EC2 instance in the private subnet. You will not have any public IP address assigned to it. Okay. You will not have any public IP address assigned to it. I mean, if you want to access this private subnet instance, you need to access it through Bastion host or SSM agent. That is the thing. You will have to access through Bastion host or SSM agent. That is the thing. And in the private subnet, you will have an auto scaling group to scale these instances. You will define like how many instances need to be scaled. That is the thing. Okay, let's get into secure subnet. I mean, this is same like private subnet only, but somewhat different to the private subnet. We'll discuss in the Terraform part and how we are assigning these things in the secure subnet. Okay, in the secure subnet, you will have an RDS database. RDS database. I mean, sorry, RDS instance, which is a multi-availability zone. Here you can see multi-availability zone, which is an RDS instance. Okay, this is the thing. Here, if you
What's
see that,
what's the difference between a private subnet and a secure subnet? Aren't they the same thing, really?
yeah, we'll be discussing in the Terraform part. I mean, when we are deploying live, I mean, I'll show the difference between them. Then, okay, they are little bit same. And I mean, 95 to 90 to 95%, they are literally same, but you will have some difference between them. Okay,
Okay. And in our infrastructure, we would create like another subnet for that.
I didn't understood. Can you say again?
We'll have three subnets
Yes.
provision. Okay.
Okay, that is like you will have this in the production also. You will have this kind of scenarios. Mm, yes. Here, if you see that application load balancer is in public subnet, right?
Mm-hmm.
If application load balancer is in public subnet, I mean, there they this is in public, right? You they there is a security breach here. If you see that in the public subnet. So we have a AWS service called WAF, Web Application Firewall. This is called, I mean, this symbol is called WAF. Okay, this secures the application load balancers responses and have a firewall kind of thing in the application load balancer when accessing the application load balancer. I mean, it is we are covering the security part also. I mean, as client said, we need to have disaster free architecture, and security need to be taken care of as 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 a priority. As a priority, I mean, even DevOps and cloud engineers need to take care of some security practices also. You can't ignore some of the things like, yes. The next thing is that all understood this VPC part, right? Anyone join new? I mean, okay, let me get into this Route 53 and AWS Certificate Manager. Okay, we'll be using an domain. We'll be purchasing an domain. Using that domain, we will create an hosted zones using the Route 53. Route 53 to the Route 53, there will be a hosted zones. That hosted zones will be connected using name servers, and I will explain that process later, but still I'm explaining the overview of it. Using Route 53, we'll be having that domain connected to each other. And yes, the next thing is that you will have a HTTPS access, not HTTP. Should, I mean, I don't have this Zoom premium, huh? Okay, let me, okay, fine. You will have AWS uh, certificate manager to generate the certificate, like a security certificate, a TLS and SLS certificate, so that the domain will have HTTPS access. That is the thing, and security will be uh, taken care of in this project. And next, coming to CloudFront, we'll discuss CloudFront in next part. Okay, I mean next thing. This is a CloudFront. How many know about CloudFront and CDN? Let me know that.
I've had some experience with it on
O-
production projects.
Okay, fine, fine, fine. That's good. That's good. Okay, let's know how CDN and CloudFront works. Okay, I mean, if you see that, it will be a little bit confusing, but I'll say about it. Let's say I'm Deepak, right? I just deployed my application in USA. Let's say you have US Central or something like that. You'll just deploy in this process in the US Central. But a guy from India a guy from Africa want to access this USA application, USA based application. So the request will go from here to here. I mean, this will take lot of time, and there will be lot of latency involved in this, right?
Right, right.
Yeah, there will be lot of latency involved in this. I mean, as I said, it is a pretty common kind of thing. You will have very latency, but there is a process in I mean, there is a concept generated from this, that is called CDN means cloud distribution network. Okay, CDN means cloud distribution network. Using that uh, using that concept, uh, as AWS have all over the world, they have servers, right? They will create something called edge servers. Let's say user is here. I mean, user will access the application from the nearest edge server that is connected to the main origin server. The user will directly access this edge server, which is connected to the origin server. By this, you will have less latency compared to this process. In this process, you have more latency, right? In this process, but in this process, you have less latency because you are accessing from the nearest edge server. That is the beauty of CDN. Okay, you will have very less latency, and the backend process of this is using of cache. Okay, cache memory. If you know that, cache memory is like a temporary memory, but still there are many advances going on in the CDN also. They are like, you can always have the dynamic content in the CDN also. I mean, if you know that a Hotstar on Netflix works on CDN, and they have a dynamic content on this. Let's discuss that dynamic content later, but I'm discussing now about static content now. In the static content, you will have the cache involved in this process, and the cache will be in the edge server, and user will access this cache website. And yes, that is a process in the CDN. Understood, right? Hello, is
Yes.
it audible? Okay, understood.
Yes, yes, you are audible.
Okay, fine,
And
fine. Okay,
yeah, we understood it.
okay, fine. I mean, yes, now we'll be discussing about multi-region, as this base architecture is like, first thing is that I'm just setting up the base. I mean, how things are working and how things are interrelated. And yes, Yes. Now multi-region, as I said. Okay. The main advantage of the multi-region is that in the production process also, you will have something like blue-green deployment strategy. Anyone know about blue-green deployment strategy? Hey guys.
The blue one is like the blue one is the current one running, and the green one is like it is for the backup one.
Uh, yeah,
Where
yeah. Okay. I mean, let me say that in the blue-green deployment strategy, blue one is like uh, version one, and green one is like version two. Okay. You want to release
Mhm.
the version two.
Okay.
You want to control the traffic using that. I mean, let's say you have 90% of the traffic here in the blue version one and 10% of the traffic to the version two. That is the thing. You can't directly deploy 100% of the traffic to version two, right?
Right.
Yes, that is the thing. In the production also, you will use them. I mean, it is like a compulsory kind of thing when you are using versions, right?
Mhm.
Yeah, that is the thing. That is why we have something like AWS Global Accelerator. Using this global accelerator, you can distribute traffic traffic across multiple availability zones, multiple regions also. That is the thing.
Okay.
That is
Okay.
the
Means
advantage.
it is basis on region, not on
Uh,
load balancer.
it will distribute the uh, traffic to. I mean, it will have some of the backend. I may not say now the backend involved in this process, but still it will. And are you saying about load balancer? Can we keep this load balancer? No, no, we can't. Load balancer is like regional, right?
Mhm.
If you see that you can only deploy in the particular region or particular availability zone, but AWS Global Accelerator is something like global. That is why we
Okay.
use AWS Global Accelerator so that you will have multiple regions, multiple availability zones, and blue green deployment strategies, and many strategies. I mean, AIB strategies, and there are many strategies involved here. Okay.
Okay.
And the second advantage, this is the first advantage, and the second advantage is that choose one of the from these two resources. Which which will you choose as a DevOps engineer?
The one with the global accelerator.
Yes, 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 yes. At the first one, if you see that there are many routers attached to it. In this process, you will have much latency, right? You,
Yes, definitely.
yes, definitely you will have much latency. AWS Global Accelerator, like it works somewhat like CDN, but uh, it is like it will have some edge locations, and it will directly have some router attached to it, and it will just reduce the latency. That is how AWS Global Accelerator. These are two great best advantages of using AWS Global Accelerators. I mean, this is a part if you want to say about, I mean, you can say in interviews, we implemented blue green deployment strategies and everything. Okay. See that. As I said about multi region, you may have one of the biggest doubt is that what is biggest devil in this multi region approach? The biggest devil in this multi region approach is database. Yes, the database part is the biggest devil. I mean, I wanted to make a separate video on this. I'll make again a separate video. I mean, how can we eliminate this data? N- how can we eliminate this devil in the multi-region approach? And yes, these are the things you need to have as a compulsory if you are dealing with the multi-region approach in the database. First one is a consistency. All clients need to see and edit the data at the same time. I mean, there should be a concurrent approach in this process, that is called consistency. You need to have data consistency across the database. And next thing is that availability. Even though some of the nodes fail, you need to have replica database available, take ready to occupy the space. That is the availability part. Next thing is that you need to have partitioning. I mean, even though system doesn't work, your database need to be present. If you learn in the DBMS subject, if you know that DBMS subject, there is something like acid properties. Acid properties. Uh, you will have all this uh, in this in the acid properties of the database management system. Those are the topics you can just refer into how databases, how databases work concurrently, and availability, and partitioning, data consistency, data replication. Yeah, there are many things on that part also. You need to learn about this concept also. If possible, I'll make a video on this topic also. It will be lengthy, but still, as I said, these are the possible problems among the multi-region approach, the database part. What are the possible solutions you may think, right? Yes, these are the possible solutions. Uh, Possible solutions. The first thing is that you need to have multiple replications across the regions. For multiple replications across the regions, the simple RDS approach doesn't work, right? Anyone worked with the RDS databases in the multi-region? Hey guys,
Yeah.
no. Okay, fine. You will work now. Okay, in the interview, you can't say no, right? Yes, yeah. That is the thing. You need to say like, I have worked. You need to just frame story around it. You can't say like, uh, yes, I think I have worked. Like you can't say the partial answers also. That is the thing. You need to frame stories in the interviews. I use it to frame like dozens of stories in my interviews. My freelance clients used to be very like they used to be very strict compared to this normal jobs or something like that. That is the thing. I used to research all these things, how to implement, and the main focus uh, of the freelance recruiters is that how do you solve problems. That is the thing we'll be focusing. As I said, uh, i I will be discussing the solutions in the later part. I will be having a YouTube video published on this also. For to implement replication across regions, you will use something like AWS Aurora Global Database. There is a AWS service called AWS Aurora Global Database. With that, you can have multiple replicas across these regions. That is the thing. Even you can store this data. If you have a static data, you can store in the S3 bucket as a replica or backup kind of thing. You can store those kind of things. And this AWS Aurora is a global database. As I said, you can have the multi-region approach here also. And next thing is that you can have NoSQL in the DynamoDB database global tables if you have other databases. And next thing is the database sharing. I may not discuss like how things happen here. As I said, we'll be discussing later in the another YouTube. YouTube video, right? Okay, fine. Finally, I mean, infra provisioning. How many of you excited for this and how many of you frustrated for this? Same,
Yes, all of us.
Yes, it is so hard. I mean, it is like, if a client says like you need to write this much of Terraform code uh for this project, it is like so much frustration though, right?
Yes.
Yes, I mean you we are writing manually all those things. It is a lot of headache. I'll give a solution for it today only. How can you generate a Terraform code and all these things? Okay. The first,
Right.
yes, yes. As I said, the next thing is a provision infra with Terraform and Crossplane. The Here we'll use a partial combination of Terraform and Crossplane. Okay, Terraform and Crossplane. We'll know the reasons to have Terraform and Crossplane because yeah, I'll discuss it later. Okay, fine. The first thing is that, as I said, we'll be using Terraform, but we need to know what are the problems of the Terraform so that we'll use some of the tools to overcome these problems, right? Do you face these problems? I mean, in the Terraform, if you face, you can say that. Okay, let me say that. Okay, once I say that, you can just we can just discuss about it. Okay, fine. The first problem is a single point of failure. This is the worst. I mean, this is the worst problem. This is like the most important problem for the. I mean, what to say? The most like what what to say, right? This is first problem we need to discuss, that is single point of failure. I mean, you will have a state file for every Terraform. When you create an infrastructure, for every infrastructure you will have it state file. If you delete that state file, the whole infrastructure is gone. I mean, you cannot say gone, but you will say that you cannot if you just apply again the Terraform apply if you click again apply the Terraform apply again, it will just create another infrastructure and there will be lot of misconfigurations around it. That's why there is a problem called single point of failure. We'll discuss how to overcome this single point of failure using some tool called Terramate. There is a tool called Terramate. You can have this problem rectified using a tool called Terramate. The Terramate will just break a state file into multiple state files, multiple micro state files, so that you can have infrastructure provisioning quickly. We'll discuss it in the later part. Okay. The next thing is that no auto drift of infrastructure. I mean, anyone know what is auto drift? Hey guys, let me know what is auto drift. Okay, let me say that. Auto
Okay,
drift means okay. Okay, say
okay,
with
let me just try. It means maybe when you have two different sets of configurations.
yes.
Yeah.
Two set of yes. Let's say you created a EC2 instance using Terraform using Terraform infrastructure as code, but someone in your organization just deleted this EC2 instance manually from the console. So Terraform can't do any auto drift, right? Can't create that EC2 instance again. That is a auto drift.
So
Understood, right?
basically, it means auto drift means recreating automatically resources that somehow
Yes.
disappear from the infrastructure
I
outside
mean,
of
from the
the
console.
code, right?
Ah, yes,
Mm-hmm,
yes,
mm-hmm.
yes, 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 yes.
Okay, okay.
I mean, yes, this is the thing. That is why we are using something like a tool called Crossplane. Anyone know about Crossplane? I mean, it is a CNCF project. Okay. It will be running in the Kubernetes cluster. That is the thing. And next thing is that next problem is that, as I said, Terraform talks with many APIs, but solely it doesn't have any control plane or own API. That is like problem. I mean, you can't talk with Terraform API until unless it is commands. You can't talk with Terraform API. That is also problem. You can't write any scripting with the Terraform API. That is why if you see that HashiCorp, the stocks are getting down. Yeah, right. Many are like they are like very much confused, and yes, that is there are many problems apart from this. We'll discuss it later. I mean, these are the main problems faced by the customers and the clients. Yes, we'll discuss the solutions of it. Here, if you see that there is a state file, if you just destroy this, I mean, if you just delete this state file by any chance, the total, I mean, you need to manually uh, import the infrastructure again. There will be a lot of manual process. Uh, I don't recommend to use solely this is like single point of failure, right? Right. Okay. Fine. Let me get into the possible solution. As I said, we'll be using Terramate. Let me introduce you to Terramate rather than just into the PPT. Okay. Are you able to see? Okay.
Yes, yes.
I mean, it is in. Yeah, this is the thing. You can automate, orchestrate, and observe Terraform with this. Let me get into the advantages of it. As I said, if you are running any CI/CD pipeline using one state file, you will have to wait uh, for this whole process to be done. But if you have multiple state files as stacks, generally in this process, state file divisions are called stacks. Using that stacks, you can run these CI/CD pipelines at a parallel process so that you will have less blast radius. As I said, here if you see that the CI/CD runtime is 10 minutes, but here it will be like 3 minutes because you are having parallel running of this Terraform file, Terraform state files, I mean Terraform infrastructure. That is the thing. You will have the clear in ownership and separation of boundaries. You can divide this into like teams kind of thing. That is the main agenda of this Terramate. I mean, why I'm saying Terramate, because there are many companies or organizations using Terraform from many years, but they can't migrate from Terraform to any other tool now. It just it is like very much costly process to have to migrate to Pulmi or some other tool like Crossplane, right? Hey guys, I want any response from you. Hello? Yeah, I can log in. Okay.
Yeah.
Should I show you demo or something like that?
Yes, you can.
Now I am in the wait list again. I have my friend's account, but still, it will take. It is a time taking process again. I will have another video about it. That is the thing. Even if you can have this detect the drifts again. If you just change in the AWS by console, automatically the code will be generated and you will have some PR raised to your GitHub. That is thing. Okay. Yeah. As I said, this is a GitOps kind of approach Terramat follows. That is the um, most used in the industry. I mean, you understand GitOps, right?
Yes.
Yeah, that is the thing. From the Git, you will be operating all these things. Let me erase this. Okay. Yeah. As I said, first part is the Terramet. We are using the Terramet to solve the problems in the Terraform. And yes, the next thing is that Crossplane. If I just implement all these things, it will take like s- say from your like experience how much time it will take to implement all this. I mean, Terraform, Crossplane, Terramate, Crossplane, and everything. Yeah, how much time it will take? I mean, to implement all this process. For a possible, I mean, I can say that at least if you are having big organization, at least 1 year to 1.5 year. That is the thing. Okay. The next thing is that, as I said, the combination of Crossplane and Terraform. You will have combination of Crossplane and Terraform. As I said, Crossplane has something like auto drifting the infrastructure. That is a main advantage. And there are many advantages, like you can manage the state files. And yes, it is better than Terraform also. But you can't migrate complete Terraform into Crossplane. That is the problem. We are addressing using Terramate so that you will have Terraform and Crossplane provisioning done in this process. Yes, as I said, the crossplane also follows GitOps approach. You will run this crossplane in the Kubernetes cluster using Argo CD. It will fetch the resources. Will fetch the resources from the GitHub. Argo CD means continuous deployment. Using continuous deployment approach, automatically uh, automatically this infrastructure will be created on AWS, GCP, DigitalOcean, and any of the cloud providers. But the main advantage of the crossplane, as I said, the auto drift. Whether if you change in the console also, automatically the auto drift policies occur and automatically the instance or anything will be created. Right? Understood? Up to now, did
Yes.
you understood? Okay. The explanation is good, right? I mean, it is good. It is good or bad? I want. Is it good or bad?
It's good
Good,
enough for
good
me.
for me.
Okay, fine. If it is good, okay, fine. Okay. Hmm. Let me. Yeah, yeah. End of discussion. Now let's implement. How many of you excited for this? Yeah, let's implement, right? End of discussion. This is a architecture. I mean, I cannot implement all these things and Crossplane and these things, but still, I'll show you how to implement. You need to do. I will implement this base architecture and this AWS Global Accelerator. Maybe I may not. I can't say. I can't guarantee that, but still, let's see if the time fits in. We can implement. My internet is very slow. Okay, fine. Here's a repository. You can fork it or just download it and have this. Yes. As I said, we'll be having multi regions, region one and region. As I said, the regions, multi region, the same infrastructure we are creating in the region two also. I mean, if you understand this region one, you will automatically understand the region two. Let me open this. Anyone know about GitHub code spaces? Have you ever worked on this?
Yes.
Okay, fine. We are using GitHub code spaces because many of them may not have the classic computers or something like that. You can use this GitHub code spaces and just have things sorted. I mean, it is very good for me also. Let me open in browser. Okay. Up to now, any doubts? Can I know? Up to now, up to this explanation, any doubts you got? You can freely unmute and just say about it. Yeah. Okay. Fine. Once I'll explain this code and all these things, you can just first thing is that main.tf. All know like Terraform, right? All of you know how to write the basic part of Terraform also.
Yes.
Yes, right? Yeah. Okay, fine. Let me continue. As I said, let me. As I said, there will be a VPC. Okay. We are creating a VPC here using a sidecar block. There is a variable.tf. Using that variable.tf, in the variable.tf, you will have sidecar. The sidecar means the range of IP addresses. IP addresses mentioned here. If you see that this is the range of default sidecar we are defining here. Here the main.tf. Here in the main.tf, there is the sidecar block defined from the variable.tf. And yes, the next thing is that we are enabling the DNS support. I mean, we need to have that Route 53, and we need to have that domain, right? That is why we are supporting this DNS support and all these things. You need to have these things enabling so that you can work on these things. And next thing is that we are giving the name AWS. Sorry, you can. It is a two-tier app, but still okay. Let's continue with that. It's a two-tier app. As I said, there is an instance and just a database. It's a two-tier app. There is a miss. Okay, let's continue with that because the naming may vary in the other resources also. That is why I'm not just changing here. Okay. As I said, if works, there is a meme in the market. Anyone know that? If code works, then it works. Yeah, right? Hello? Am I audible? I mean, okay, fine. Are you able to mute yourself? Other guys? Okay, fine. Fine. As I said, we will be having this subnets, public subnets. As a, let me give that architectural. We'll keep that architecture aside. Hey, shit, this thing doesn't work. Okay. Here, if you see that we have a VPC, as I said, public subnet. First thing is that public subnet. These are the public subnets mentioned. This is a VPC ID. We are fetching the VPC ID from this AWS VPC dot my VPC dot ID, and there is a sideR. We need to mention the sideR in this subnets also. As I said, the availability zone is AP South 1A. You can change according to your requirement. AP South 1 means the Mumbai region, which is near to me. I am from Hyderabad, India. That is why I am using AP South 1A. And next thing is that AP South 1B. Okay. In the public subnet, you will have map public IP on launch equal to true. I mean, using this option, you will have a public IP for the public subnet, right? Okay. The same things here and here. These are public subnets in the different availability zones. And next thing is that, as I said, we'll be having a internet gateway. A internet gateway here. When switching the tabs is hard. Okay. Here, if you see that we have an internet gateway, public subnet is completed. Here we have internet gateway. This is the main.tf. We'll get into the NAT gateways and that things later. But okay, here is the internet gateway. We need to, and next thing is the route table. Route table. All know about route tables, right?
Yes.
Yes. Because I cannot explain how route table works and all those things, right?
No,
If
no need. You can proceed further.
yeah. That is the thing. Okay, fine. Yeah. I mean, you need to have a route table to reach the correct, correct, what to say, correct load balancer or something like that. That is why we will be using a route table and correct internet gateway. Here, if you see that this route table is attached to the internet gateway. Okay. This route table is attached to the internet gateway. You will be defining the sideR block for it also. Okay. This is a VPC ID as mentioned. I mean, Terraform writing is not that hard. I mean, if you compare to other things, it is just declarative kind of thing. Even if you generate from the Terramet, as I said, Terramet will also generate this Terraform code for you. You can generate from this also, but still, it is not that hard, right? Yeah, that is the thing. The next thing is that uh, you need to you just created the route table here, but you need to associate this route tables to the subnets, right? you need to attach this uh, route table to the subnet. That is the main. Here we create a resource called AWS route table association. This is a subnet ID. I mean, here if you see that this is a subnet 1, subnet 2 in the public subnets, you will attach this route table association resource to the subnets, right? Okay. The next thing is that you will have a security group. You need to define all these things. It is a time taking process, but still it is worth it to have infrastructure as code tool in your organization. Okay. Uh, Here, this is a basic one. We are inbound rules 8080 as a TCP so that your application can run on the 80 port. Okay. Ingress port 22. Port 22 is mainly used for public, I mean, what to say, access, access the instance or something like that. Access the instance and just troubleshoot kind of things. Yes. The next thing is that egress. Egress means outbound rules. You can have 0 to 0 as a port. You can just ignore if you want it. Okay. It is very much mandatory to have a tag. Yes, we are mentioning tags for everything here. If you see that we are having tag for VPC, and we are having, you can mention in the for the subnets also, but not mentioned now. It is not good practice to have uh, good practice not to mention tags. I mean, it is good practice to have tags. Okay, that is a thing. Okay, the first thing completed. I mean, the public subnet. We created a public subnet and internet gateway in the two availability zones. And yes, the next thing, the private subnet. Sorry, the NAT gateways, right? We okay. Next thing is the NAT gateways. For anyone know prerequisite for the NAT gateways before creating the NAT gateways? What need to be created? I mean, yes. Yeah, there is like elastic IPs need to be created before creating the NAT gateways, because every NAT gateway has something like elastic IPs to mask the IP addresses. That is the thing. The prerequisite before creating the NAT gateways is elastic IPs. These are the two elastic IPs we are creating because we have two NAT gateways created in two availability zones. Yeah, that is the thing. And the next thing is that we are creating simple NAT gateways from these two elastic IPs. Allocation ID, you can just pass this allocation ID from this NAT gateways. Yes, that is the thing. Okay. Up to this, internet gateway, BPC, public subnets, NAT gateways is completed. Let's get into the next part. Private. We'll discuss later about this application load balancer, auto scaling, and RDS in another Terraform file. For now, let's discuss the main structure of the architecture. The next thing is that the private subnet. Here, if you see that here is the private subnet. Someone asked like, what is the difference between private subnet and public subnet, right?
Yes.
Yeah. Here, if you see that there is something like map public IP on launch equal to false. I mean, it will not have any public IP address. That is the main difference between private subnet and public subnet. And it you can't access without public IP address, right? There is some other process involved to access the public private subnet, that is called Bastion host or SSM agent. Anyone worked with that Bastion or SSM agent?
Yes. Bastion is basically setting up this two machine that
Yeah,
can
yeah.
access to the private subnet.
Yes. That is the thing. Uh,
Mm.
yes. Here are the two private sub. Yeah. As I said about public subnet part, let's get into the next part, which is like uh, yeah, let's get into the more details into the public subnet, which we have a NAT gateway here. If you see that in the public subnet, okay, we have a NAT gateways. For each to allocate a NAT gateway, we need to have something like elastic IPs associate before the NAT gateway association to mask the IP addresses. NAT gateway does the operations like masking the IP address. The prerequisite for having the uh, NAT gateway is that allocate a elastic IP addresses as we have two NAT gateways in two availability zones in two subnets by precise. We need to have two elastic IPs and two NAT gateways. The next thing is that we have a private subnet asset private subnet. In the private subnet, we have something like you don't have any public IP for the private subnet part. And yes, if you want to access, you need to access through Bastion host or SSM agent. SSM agent is a AWS managed service. You can use that because in interviews also they will ask about why to you why to use SSM agent rather than Bastion host. You can say that SSM agent is AWS managed service and Bastion host needs to have some servers that usually deals with cost. So better to use SSM, which is managed by AWS, and it will be better for sure if you use AWS managed service rather than our own custom things. Yeah, that's what you can say when interviewer asked about uh, why you should use SSM rather than Bastion host. Yeah. The next thing is that as I said, we'll be using SSM agent to troubleshoot things in the private subnet. Okay. The next thing is route table association. As the same thing. I mean, uh, there is uh, there is only one difference between public and private subnet. Uh, the In the private subnet there will be no public IP associated. In the public subnet there will be public IP associated. Yes, that is only difference. Rest of it, the same thing. You will have the route table association. Here, if you see that there is a route table, we are creating two route tables and two route table associating with the subnet. Yes, you need to implicitly create all the things in the Terraform. Uh, the things, the things you need to understand in the cloud. Uh, Through the manual may differ here. I mean, AWS does it all for you, but in the Terraform you need to do all the things, put it here as a code. That is why it is called infrastructure as code. There are many advantages to the Terraform also. We'll discuss it later. Okay. The next thing is that, as I said, we'll be associating the route tables to the things. Here is a route tables, two route tables and two route tables associations to the private subnet. Okay. Yes. Here, if you see that the private subnet part is also completed. Uh, we will discuss about application load balancer and auto scaling group and this RDS later, but we are implementing the foundational structure of the thing like public subnet, private subnet, and secure subnet. Okay. The next thing is that we have secure subnet. Okay. I mean, yeah, as I said, I'll be saying about difference between private subnet and secure subnet. Yes, this is a part. Okay, if you want to say about difference between private and secure subnet, yes. Here, if you see that there is a secure subnet. Yes, as I said, in the secure subnet also you will not have any public IP addresses. If you want to access, I mean, you can't access. You can access through SSM, but that is a difficult process again. Okay, you need to have you will have some endpoint. Through that you can just access the things, rather than the things I'll be saying later, but still you can research on this also, what is secure subnet and all these things. Okay, here is a secure subnet. There is a CIDR range for every resource, every subnet, every VPC we are creating. You must know that. I mean, the fundamental concepts are those. And the next thing is that here we have a public IP on launch equal to false. Will not have any public IP. And tagging, we must have tags for every resource. And here is the second secure subnet in second availability zones. As I said in the pictorial form here, if you see that, you will have two secure subnets on two availability zones, two private subnet in two availability zones, two public subnet in two availability zones. Yes. As I said, okay. Here is the difference between private subnet and private subnet and secure subnet. Okay. Here, if you see that in the private subnet, you will have a route table and route table associations. Okay. Why you will have route table and route table associations? You may have question, right? Why you will have route table and route table associations? Route table means what? It just passes the route from the subnets to the desired path, right? That is the definition of route. Again, here if you see that there is a public subnet. In the public subnet we have instances. These instances need to be accessed by the application load balancer in the public subnet, right? So that we need to have something like routes. That is the thing. We will be having something called route table and route table associations in the private subnet. Okay, that is the thing. We'll be having something like route table and route table association. These are the route tables and the route table association. But when it comes to the secure subnet, here if you see that when it comes to the secure subnet, we have a database. I mean, database. There is a concept called uh, mm, there is a concept called security. In that security part, we need to constrain the database in a very secure part. If you just have things things not secure in the database part, your organization may affect in that. That is why keeping security in the part, we will have in the secure subnet. I mean, you may have doubt that what is the difference, say Deepak. I mean, you are just saying about these things. Okay, here is the difference. Here in the secure subnet, you will not have any route tables and route table associations. Okay, here in the secure subnet, you will not have any route tables and route table associations. There are two simple subnets. That's it. There are no route tables and route table association. Whereas uh, in the private subnet, here if you see private subnet, you will have two route tables and two route table associations, because you need to access it through the application load balancer. That is why you will have these two route tables and two route tables associations in the private subnet. Whereas comes to the secure subnet, you will not have any route tables and route table associations. That is the difference between private subnet and secure subnet. In the interviews also you can say that difference between private and public subnet, sorry, private and secure subnet, as there are no route tables uh, in this process. Again, if you just create from the console, you may not visible these kind of things. That is why Terraform is important for the organizations also, to have that security point of view and many things. You can have that custom kind of things also in the Terraform. That is why Terraform is famous, but still uh, there are many problems, as I discussed earlier. How to recover also I discussed. Okay. 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 The next, as I said about foundational structure. Okay. I mean, yeah, this is a foundational structure. Here, public subnet, private subnet, and secure subnet. We'll discuss about these things. I mean, what are inside of this application load balancer? Okay. First thing is that application load balancer. Let me see that. Where is ALB? Yeah, here is the application load balancer. Okay. I mean, application load balancer is a resource, as I said, is a resource which distributes the traffic into across the regions. Sorry, across the what to say across the compute. Let's say you have a EC2 instance, you need to distribute. You have two EC2 instances. You need to distribute the traffic to two EC2 instances or many EC2 instances as per requirements. You will have the this load balancer so that you can distribute. That is the main function of the application load balancer. There are many load balancer you can explore also. There is like network load balancer NLB. You can also explore that, and you can always integrate that. Yes, here is a resource application load balancer. Yes, you will have a security group. As I said, for every load balancer, there will be a security group to have those kind of things. Let's say this this application load balancer need to access some DNS, a DNS, uh, DNS, so that we'll have some security group. Okay, let's get into the security group part. I mean, yeah, application load balancer ka security group. This is a application load balancer security group. Here, if you see that for HTTP access, this 80 port has been enabled, and our application runs on 80. That is why 80 port has been enabled. And ingress means we are inbound rules. Okay, inbound rules. Egress means outbound rules. Okay. Here, if you see that for 443 port, there is a HTTPS access provided. That is why we are allowing only certain range of ports. Egress means outbound ports, outbound rules. Okay, yeah, this is this is the application load balancer ka security group. As I said about application load balancer, for the creation of application load balancer, there are some things need to be taken care of, because application load balancer needs something like application load balancer target group. Okay, here is the application load balancer target group. As we are targeting uh, instances like EC2 instances, that is our target group, and the port which application will be running on is 80, and the protocol is HTTP. Let's again, after this part, you can always integrate into HTTPS also. S stands for security. You can have some AWS certificate. You can integrate with AWS certificate manager and get that certificate sorted. Okay. Here is the standard things like health checks, to have that easy to know that application is running or not. Yeah. The next thing is that here is the thing. Next thing is that AWS load balancer listener. Okay, for every application load balancer, you will have something like target groups and a listener to have configurations correctly. Yes, these are the things. Okay, application load balancer listener and target groups. These are the things you will have for every application load balancer, and a security group also. These are the things. Application load balancer, there will be security group, uh, target group, and a listener. These are the things you will be having when creating the application load balancer. And yeah, as I said, we'll be creating in the public subnet. Here, if you see that the subnets is subnet1 dot subnet2 dot id. Yeah, these are public subnets. Okay, give me 1 minute. Yeah, as I said, we created the application load balancer. I explained about application load balancer in the public subnet. Let's get into the auto scaling group. Where is this auto? Okay, auto scaling group. Here is the auto scaling group. Here, if you see that there is a few lines of code. Okay, let me explain this how things happening. Okay, as I said in the first part, we have something like AWS AMI. Okay, AWS AMI. In the first part, let me. Yeah, we have something like AWS AMI. AWS AMI. Yeah, we will have some AWS AMI. Using that AMI, we'll be using in the third part, as I said, as I promised. We'll be using that AMI in the third part, in this part, okay? In this part, here if you see that these are the configurations done to have to use that AMI. You can just fill out these values from the AWS documentation or Terraform documentation. These are things like you are just passing the AMI data to the auto scaling group, okay? Defining this data to pass to the auto scaling group. The next thing is that you will have an IAM role, okay, for auto scaling group. Okay, let me get into the architecture so that you will have some understanding. Okay, for auto scaling group, there will be an IAM role attached to it. Auto scaling group, there will be an IAM role attached to it. Uh, you may ask why IAM role is attached to the auto scaling group, because auto scaling group takes care of based on the traffic, just rollouts the instances. Uh, Auto scaling group creates these instances from these from the traffic range and all these things. That's why to create these instances for every service, there is something called there is something called IAM role. That's why we are creating an IAM role to create the EC2 instances as per the traffic or something like that. Okay, here is the IAM role. Okay, you can just see from official documentation of Terraform, or even AWS gives these things in in their documentation. Okay, you can check that. These are the things defined, like how this IAM role and what are the policies. Like we have attached S3 full access. You can remove S3 full access if you want. Okay, this is EC2 full access, so that EC2 you can have configuration of EC2 instances creation and all these things happening, and yes, rolling out of EC2 instances happening. Okay, these are the things defined. I mean, IAM role and EC2 instances creation role policies. Sorry, yeah. As I said about AMI, we are just passing this data to the auto scaling group. Here is the thing. The next thing is that launch templates. As I said, we'll be using this auto scale. Sorry, AMI data. Here we'll be using this data. You can see that image ID equal to data dot AWS AMI dot Amazon Linux 2 dot ID. This is the thing we are referring, that data dot AWS AMI dot Amazon Linux 2 dot AMI. That is the thing ID. Sorry, dot ID. Sorry. Yeah, that is the thing we are referring to have that AMI used in this auto scaling group. Okay, so that all the softwares are been correctly installed. Okay, if you didn't watch this what is AMI and how to create that, watch part 1 in my YouTube channel. You can just check it out in the link in the description. Okay, and the instance type can be T2 micro. Okay, this is a basic. I mean, we are not having that T2. T2 large or something like that, we'll just create in the T2 micro. T2 micro is basically enough for us. Okay, here is the thing, the next part, next thing, okay. User data equal to, like, we are, let me explain to the this this architectural view. Here, if you see that auto scaling group is connected to database, uh, database instance. Okay, you may have doubt that how we'll be connecting this auto scaling group to the database, because uh, database is in secure subnet, and Deepak, you said that secure subnet uh, doesn't have any route tables, and how do you route the things from auto scaling group to database? Yeah, that may be your doubt. Yeah, I'll be explaining that. There is something like uh, endpoints for every database instance, RDS instance, so that we'll be connecting that auto scaling group to the RDS using the RDS endpoint. That is the thing. Here, if you see that user data equal to, there will be something like user data. I'll be explaining that user data dot sh shell script. Okay, that is a basically shell script will be running on the top of this my MySQL URL. Okay, here if you see that this is the endpoint we'll be using to connect to the AWS AWS auto scaling group. Okay, AWS auto scaling group will be connected to RDS instance using some endpoint, using some RDS instance endpoint. That is the process happening, and these endpoints are very much secure rather than the routing part. I mean, yeah, these are pretty much secure, and you will not have any uh, classy things like ports or something like that. That is why these are secure. Okay. Okay. There will be security group also. I mean, for this, you can just check it out. As I said, we'll be using the same VPC. Yeah, that's why security groups also not compromised. Yeah, here is the main part. These are the prerequisites. I mean, you need to have, as I said, these AMI, IAM role, and launch template. Yeah, these are the prerequisite to create an auto scaling group. These are the four prerequisites. First one is AMI and AMI data, IAM role, and launch template. And these are the four things. You can just explore this if you want. You can just see how things are working, and just comment it in the comment section in the YouTube channel. Okay, so that uh, deserving candidates can get insights from you. Okay, here is the thing. The next thing is that creating the auto scaling group. That is the main thing. Here, if you see that desired capacity, max size, min size, these are the things you are explicitly defining that how many instances need to be there at a minimum minimum runtime, something like that, minimum traffic. You can have two or one instance as per your requirements. Okay, as I said, this depends on application load balancer. Yeah, as there is a connection between application load balancer and auto scaling group, we need to have this line defined so that you will have that things sorted. Okay, as I said, we'll be having target groups from the application load balancer. This application load balancer ka target group is directly connected to the auto scaling group, so that uh, so that traffic can be evenly distributed. Okay, as I said, the health check type equal to EC2. We are using EC2 type of instances. Okay. As I said, we'll be using this launch templates. Yeah, these are the launch templates. Okay. Launch template. Yeah, this is a launch template. In the launch template, basically you will have that AMIs, nothing but AMI, and this like endpoint will be connected to that, so that you will have all the things at you will have all the things segregated so that you can evenly understand. If I just mix this launch template in this auto scaling group, you may not understand. That's why I created explicitly the launch template, and it is good practice to have uh, like separate paths for each thing. That is a good practice. Yes, here if you see that we are just passing the launch template ID so that you will have AMI and this uh, RDS endpoint pass it through the auto scaling group. Yeah, the next thing is that we are just tagging the value on the value, tagging the value, and here is the key AG key. You can just see that propagate at launch equal to true so that you will have auto scaling group running. Okay, as said, auto scaling group will be connected to uh, RDS instance using this thing. And the next thing is that one more thing I forgot to say, that there is something like web application firewall uh, when connected to application load balancer, so that you will have that security practices followed. Okay, for every application load balancer, let's say user is accessing from outside, hitting this route 53, automatically this will route to the web application firewall and check that user doesn't doesn't have that security breaches and all these things, and just pass it to the application load balancer so that security doesn't compromise in this process. That is why we'll be using web application firewall. This is a symbol of web application firewall. Okay, web application firewall. Yeah, yeah. The next thing, as I said, these parts are complete: public subnet, NAT gateway, application load balancer, private subnet, auto scaling group. Yeah, auto scaling group will automatically create these instances. No need to worry about these instances. As I said, auto scaling will group will be having something like IAM role. IAM role to create IAM permission to create these instances so that things happen automatically. Yeah, yeah. The next thing is that we will be creating this RDS instance. Okay, RDS RDS instance. Let me get into the RDS instance. Yeah, this is the RDS instance configuration. Here, if you see that there is a security group attached to the RDS instance so that you will have something like Aurora access also. You can ignore this if you want, but still, these are the things needed when you are following in the multi-region approach. Aurora is very much important when you are following multi-region approach and blue-green deployment strategies. That is why I have enabled this Aurora access so that you will have that blue-green deployment strategies enabled. Yeah, these are the things having that said, uh, having that said, 3306 is the port to have the MySQL access. Okay, this is the inbound rules specified. Okay, this is a security part. This is a prerequisite, you can say that, but still you can ignore if you want. I'm saying for the situation based things. Okay, advanced situation based things like multi-region and all these things. Okay, this is a part for multi-region if you want. Okay, the next thing is that there need to be subnet association. As said, we'll be using secure subnet. Okay, here if you see that this is secure subnet, in the secure subnet we are placing the RDS instance. Okay, we are just passing the credit this thing so that you will have the RDS instance in the secure subnet. You can just have the tag as DB secure subnet. We are not creating here secure subnet. We are just passing the things from the subnets which are already created. Okay, that is the thing. Okay, the next thing is that the main thing, database instance. Yeah, these are the things you can just pass things like the engine is MySQL and identifier equal to pet clinic, username pet clinic, password is pet clinic, and the instance type is db.t3 micro, t3.micro. Yeah, you can have allocated storage at 20 as per your requirements. I'm not saying that you cannot have more things, more GB of storage, you can have it as per your requirements. And here is the thing, you will have to pass this. Okay, you will have to pass this application load balancer security group, which is this security group. This is the security group which will be passing. Okay. The next thing is that availability zone. You can define according to your availability zone, AP South 1A, and you can always have two availability zones also. Okay. These are the things happening in the secure subnet. As I said, this is a secure subnet, and yes, will be uh, connecting this secure subnet RDS instance through autoscaling group through RDS endpoint. Okay, this will be connected, and this will be connected to the EC2 instances so that you can access the application through application load balancer. Yeah, let me get into for 1 minute. I think I have some things to discuss. One minute, I'll just. Okay, 1 minute, I'll just need to have some things. Yeah, as I said about database instance. Okay, database instance. I mean RDS instance will be connecting this RDS instance through application. Sorry, endpoint. Endpoint will be passed through it, and let's discuss about some things so that you will have more clarity about something. Okay. Here, if we see that there is auto scaling group, as I said, I will be discussing it about later. Okay, this is the thing we'll be discussing now. Here is the thing. There is a template file user data.sh will be passed through the auto scaling group so that you will have some things running. Where if you see that there is a EC2 instance running through the auto scaling group in the private subnet in the private subnet. Okay, here if you see that user data.sh is passed from the application load balancer and a endpoint is passed. Okay, you may have doubt like what is the user data.sh. Let's get into it. Here is the user data.sh. Okay, this is a basically a shell script uh, to have things running. Basically, let's say I'll say about workflow. Let's say a user accessed from auto scaling group. Let's say we just created using Terraform. First, it will create auto scaling group. I mean, First it will create autoscaling group. After autoscaling group will automatically create these instances using this user data.sh and AMI. Okay, and AMI. I'm not saying only AMI. I'm saying user data.sh and AMI. It will take some things from user data.sh and AMI. This user data.sh will be running on these instances. Basically, this user data.sh will be running on these instances. If you see that, what are the things will be running on these instances? Uh, Here if you see that we are just updating the things and just installing docker and containerd. We'll be using the yum package because as we'll be using the linux or CentOS flavor, that is why we'll be using yum as a package manager. Okay, then the next thing is that sleep one, so that you will not have any misconfigurations occurred. Okay, these are basically simple things. You are just executing the permission chmod plus it, so that you will have permissions granted granted for it. Okay, sleep 5 means 5 seconds to have that sleep, and we are just enabling the docker service so that docker is up and running. Yeah, the next thing is that we are adding user, Docker as a user, and we are adding SSM so that you can troubleshoot things. I'll be explaining about SSM later, but still. Okay, these are the things will be happening at your organization also. You will be having something like user data.sh plus an AMI. As I said, not no only AMI. We can't run all these things like Docker run, Docker pull, all these things. So that we'll be having this user data.sh also, so that automatically when Terraform scripts run, uh, Terraform apply will be run automatically. This instances will be created, and this user data.sh will be running on this instances respectively. Yeah, the next thing is that we'll be pulling some Docker image. Yeah, in the part 2 we have created some Docker image using some Docker build and all these things. Yeah, this is a Docker image Deepak 8934 pet app 66. Okay, this is a Docker image will be running. Yeah, this is a Docker minus E. You may think, what are all these things? Let me explain it from the official documentation of the things that we picked from. Okay, let me get into that part. Right. Here, if you see that, see the what? Yeah, 1 minute. Let me, as I said about second part. Okay. Yeah, this is a documentation of sample clinic application. Here, if you see that to run the database of the application, there is something like some things need to be followed on. These are the things picked from the documentation only. Here, if you see that, yes, let me get into it. Yeah. Here, if you say that minus E MySQL user equal to pet clinic. I mean, these are the things you need to pass to have things working on. And we are using MySQL rather than Postgres. That is why I am using these things. And as I said, 3306 will be port open. Port open on the database part, so that MySQL will be configured correctly. Yeah, these are the things we are just passing the endpoint according to that. Yeah, this is the MySQL URL which we just declared in the auto scaling group. Yeah, MySQL URL equal to AWS database instance dot db instance dot endpoint. Okay, yeah, these are the things we'll be passing a password equal to pet clinic and MySQL root password equal to root, so that EC2 instances can access this database and endpoint will be directly connected. Yeah, as I said, these are the things. You may have some confusion between this, but still, you need to follow some official documentation. And yes, if you want to uh, connect the RDS instance to the uh, to the EC2 instance, these things need to be followed down in the Docker image running. Yes, these are the things. Minus e equal to MySQL equal to. We are just passing the RDS, sorry, MySQL URL endpoint, and yes, we are passing the password and credentials. The next thing is that we are doing some port mapping. Okay, port mapping 8, as we'll be running the application on port 80. As I said before, we'll be running the application on port 80. Okay, we are just mapping to 8080 so that application is successfully running. Here is the thing uh, mentioned, so that things will be the Docker image is successfully running. Yeah, this is a uh, user data.sh. I think I have explained a lot of things in this process. Okay, yeah, yeah, you can explore more about these things if you want. Okay, let me just cross share and just, yeah, that is the thing we have done. I mean, I think I have explained all the things. Yeah, let's build it. Let's see what just happens again. Where is this terminal? Terminal. Okay, new terminal. Let me ls cd. Let me see if I run. Yeah, yep. These are the things we have. Let's do host Terraform init so that initial configuration will be done and it will say about misconfiguration, if any misconfigurations or syntax errors. Okay, as I said, there will be an backend will be initialized. Yeah, let's do Terraform plan. Okay, these are the things will be added when we will apply Terraform apply. Okay, yeah, let's see what are the things added. There are many. Let's not dis. You need to see what are the things added also. Auto scaling group. Okay, auto scaling group, launch templates, database instance. Yeah, subnet groups, elastic IP addresses, NAT gateway, many things, EC2 instances, IAM roles, IAM role full access, EC2 full access for the auto scaling group. Yeah, these are the things we have around 40 plus resources. Yeah, 40 exact precise to be 40 resources to be added. Let's do Terraform apply so that we can explore more. Terraform apply. Yeah, 40 resources need to be updated. Okay. Yeah, this will take some time. Up to that, let's get into the architectural view. Yeah, yeah. As I said about this architecture, okay, we'll be having web application firewall also. Okay, let's discuss about Route 53. How do we have that domain and all these things? Let me see if I have some domain. I think I have some domain from .tech domains. Let me see if I have that. I think I have it. Let me just log in. Okay, I think I need to just stop share. Okay, I'll just pass my credentials. After that, I'll share my screen. Okay. Okay. Why it's showing that password is wrong? Okay. Let me try it again. Okay. Okay. Give me 2 minutes. I'll just pass my credentials. It's taking time to this. Yeah. As I said, I brought a domain. Okay, for around $12. I think so. I'm not forcing you to have domain. Okay, but still, this thing I bought for $12 for my billion. I think I brought around. Let me see it again. Okay, it is showing that full information. Yeah, this is the thing I bought around February 27th. Okay, that is a long time. Okay. Yeah, if you know that, okay, let me see that how much things are completed. Oh shit, I didn't see this. I mean, yeah, Terraform is fast. The creation is completed. Let's see that. Let me see if any instances are logged in. I'm sorry, are created. Okay. Yeah. T2 micro instances created. Yeah. The next thing is that load balancers. Yeah. Load balancers are created. Let me see that any auto scaling groups are created. In the EC2 dashboard, you can see that auto scaling group and load balancer. Yeah. Auto scaling groups are also created. Yeah. My launch template. Yeah. This is a launch template we'll be using, and there will be something like AMI in that, and we'll be using that for having some configurations. Auto scaling group is successfully created. Okay. And load balancer is successfully created, and elastic IPs for the NAT gateways. Yeah, let me see NAT gateways if possible. Okay. Yeah, two NAT gateways and two availability zones. As I said, two NAT gateways and two availability zones are been successfully created. Let me just verify. Let me see application is working or not. Let me get into application load balancer console and access through DNS. DNS. Okay. Let me see this. Yeah, this is a public DNS name. Let me access this. Let me see if application is working or not. Yeah, yeah, the application is working, and let's see if database is working or not. Ready. Why not find this? Okay. Let me just add owner. Deepak, ready. VV, Hyderabad, 1, 2, 3, 4, 5. Yeah, add owner. You can just edit the owner and add new pet. You can just buy something. Uh, Goldie maybe. My pet. Sorry, Oi. My pet name is Oi. I'll just add it. Add. Sorry, it's cat. I'm a cat lover though. Yeah, let's see. Its birth date maybe June 6th, 2nd, 2023. Okay. This is the birth date of its. Yeah. These are the things. Let's find owner by. Okay. Let's find by. Yeah. Ready? Find owner. Yeah. The database is also working fine. We are able to have that read write operations successfully. Let's see it from console how things are working. RDS, sorry, RDS. Okay, here if you see that database instances, 1 out of 20. Yeah, here if you see that there is a pet clinic database. Yeah, This is the thing, pet clinic, and all the things are successfully done. Here, if you see that, this is a very much important if you're going to get into. Uh, this is the thing, you can just convert this deployment into multi-availability zone deployment. And the next thing is that create blue-green deployment. As I said in the starting strategy, you can within one click you can just have blue-green deployment, but still have that Terraform part also. Have that Terraform part also running so that you will have all the things sorted. You cannot have some partial kind of things. That is why I uh, always encourage that you should have a strong knowledge of Terraform so that all the things you can create within Terraform only. No need to create through click kind of things, but it is pretty much easy to create from here. But still, Terraform is very much recommended. Yeah, you can have blue green deployment. You can have Aurora. As I said, Aurora is very much important when you are having that uh, something like multi-region approaches. That is why you can have Aurora blue green deployment. Why these all options are coming, you may have that doubt, right? Here, if you see that in the RDS, this is a security group. On the security group, we are enabling this access called Aurora or MySQL access, and this port 3306 has been enabled. That is why these all options are also enabled if you want to just have that. That is why it is important to have these options to be explored. Yes, I always prefer to have this explored. Okay, here's the monitoring part. You can just monitor using CloudWatch, and there are many other tools like Datadog and Nagios. You can always explore those part also. There are many advanced tools also to have database monitoring. There is something new coming into the market called EBBF. You can always explore that kernel level monitoring system. Okay, there are many monitoring things you can have that part into. As I said, this application has been successfully deployed. Let me see about this domains part, how we can just integrate, because I just purchased the domain, but still I need to integrate this with Route 53. That is a part pending. Let me see Route 53. Oh, my caps lock is enabled. Okay, fine. Let me disable it. Yeah, hosted zone is also created. Fine. That's great. Okay, fine. It is public again. Hosted zone is also created. And yes, it is connected, I think so. Using that things. I think we need to connect this instance, sorry, Route 53 to the application load balancer. That is thing it is pending. Let me see how we can connect this. Yeah, as I said about route tables, sorry, uh, Route 53, okay. Route 53, as we created the records, okay. Here, if you see that in the domain registration website, this is called .tech domains, okay. In the name servers, there are 4 name servers named NS10 something like that. These things need to be exactly matched down here, things like this. You need to create some hosted zone so that these things will be exactly matched with this. You need to just fill up this in the website where you create purchased the domain, so that automatically these name servers will be updated and the hosted zones will be updated to use in the AWS ecosystem. Yeah, these are the four name servers you will be creating using hosted zones. Okay. The next thing is that to connect this route 53 to connect, let me show you from the architectural point of view. Yeah, here if you see that there is a route 53 attached to this application load balancer using web application firewall. Okay, this is routing the traffic to application load balance from the application load balancer. That is why we'll be creating a record to connect these things. Here is the thing, creating the record. Let's leave it as a blank as we are creating on the root domain. Yeah, let's keep it as a pet clinic if possible. Okay, we'll just keep it as alias so that we'll have some things. We'll be routing to application load balancer or classic load balancer. Okay, and the region is Mumbai, and the choose load balancer dual stack. Okay, this is a load balancer we'll be using, as only one load balancer is there, public load balancer, that too. The simple routing. Yeah, your existing records, these are the existing records. We need to just create a record. This takes some minutes to have things sorted. Yeah, let me see the view status so that how things are happening. Yeah, it is in pending state. Up to that, let's wait. Okay, let me just stop sharing. Yeah, let me see it once again. Okay, let me see that. Is it working or not? I mean, we don't have a certificate, so HTTP, only HTTP, there is no security part. But oh shit, it is giving some typo or something like that. I mean, it generally takes time to have. So let's, I think, did we just miss some things? These are correct only, right? Because it is giving a response, but still we are not getting any response though. Let's wait. I think so. Yo, Finio, I think we are routing to pet clinic, right? It is taking application load balancer is working fine, but still this Route 53 part. Yeah, DNS is very tricky. I mean, I can show all this demos part, but still it takes so much of time to just do all these things. Okay, it is very much tricky. Okay, when one of the tweet of famous DevOps and Cloud engineer is, if you just troubleshoot all these things, the final problem will be only DNS problem. Because let's say you have a Kubernetes cluster, a node is talking with another node. I mean, a pod is talking with another pod using some secure TLS certificates. Let's say that secure TLS certificates dot expired, so that two pods cannot talk to each other. Then there is a DNS problem occurred. You will see all these things. I mean, crash, loop backup errors on all these things. You will troubleshoot like. In the sense of pod, but still there is a DNS problem where you can these pods cannot be talked with each other using certificates, because certificates got expired. That is the things. I mean, DNS is very much. I think it is not complex, but still it is very much in-depth concept if you want to explore. Okay, I mean it is. I think it is good, but why I'm not getting the output too? Yeah, the dual stack load balancer is correctly configured. We are using that dual stack load balancer only. Let me say that. Yeah, it is configured. Let's see if I am able to. Yeah, learn with Deepak.tech. There is no any spelling mistakes, but why it is? I think there is a problem from them side if possible. Okay, I don't know why it is not able to route the traffic. Okay, for this I'm stopping the session because it it may be laggy, because these things are very much if you want to know. Okay, I mean, not very much complex, but still, you can just troubleshoot into the part. I'll just discuss the solution also after this things. I'll just spend some time on this. I didn't spend that much time on this, so that is why it is taking some time to have. I think I need to have this through Terraform also. That is the thing. Yeah. These are the things we have discussed, and we have done only for region 1. As I said, for the region 2 also the same things you will be doing. Okay, the region 2 also the same things you will be doing. Let me see about this global accelerator part so that you guys will have. Yeah, after you just register these all these things. I mean, set up your Route 53 uh, using hosted zones and just all the things. You need to go to this global accelerator thing and just click on create accelerator and give your domain name, which is that domain name, and you can have the custom routing according to your things. I mean, blue green deployment strategies. Yeah, you can give the tags. Okay, let me just uh, sample SEC standard routing. Okay, a okay. Next, you can have listeners so that all these things are being counted. Okay, I mean same like application load balancer. Only you will have some listeners. Let me just go next. Yeah, you can have endpoint groups. Okay, explore about it. I mean, I'm just saying minimal about this, but still explore about it. There are many things happening. Okay, you can see the benefits and all these things. You can have disaster recovery and multi-region, as I said about multi-region and multi-availability zone resiliency. Yeah, you can just click on learn more to have those things. Yeah, yeah. As I said about uh, AWS Global Accelerator. I mean, if I have that Route 53 working, I will show this accelerator part also, but still it is not able to route the things. I don't know what's the problem. Okay, okay, you can integrate the cloud front also. You need to just give the domain name. That's it, and create the listeners if possible, and all these things. Cloud front. Yeah, you can explore this. Yeah, you can explore this. I mean, how things are reducing latency, and you will have this edge locations. And yes, that's it from me. I mean, yeah, I think this project helped you a lot in learning so many new things. I hope you liked it. I hope you like this kind of videos. Okay. If you like this kind of videos, and just comment it down in my YouTube in this video, and just uh, I'll this is kind of encouraging for me to have more videos published on my YouTube channel. I know that uh, videos are getting late, but still I'll just I promise that from next time it will be, not so late. Due to some things, it has to be become late. That's why That's why the videos are late. Okay. Let me know what's the feedback of this project, how you enjoyed this project, and I mean, what are the negatives of this project also, what we can include also. Okay, let me know that. Yeah, let's meet again. Thank you. Until then, goodbye. Bye bye.